In this chapter, chapter 4, we're going to talk about some methods for determining whether or not there is a correlation or even an association between two variables, two quantitative variables, and whether or not that correlation is linear. Now, we're going to talk about how to identify this linear association and some other ways for us to analyze the differences in what we expect to have happen. We're going to start with section 4.1, discussing not only scatter diagrams, but also correlation. Let's look at this introductory example on golf club speed. Here we have the data that we want to investigate that's going to look at the relation between club head speed and the distance the ball is going to travel. So here in this table, you'll notice that I have two columns, and here on the leftmost column we have the club head speed, and then on the right hand column we have the distance that the ball traveled after it was hit from the club. Now you may remember from previous discussions about our variables, this variable here, the club head speed, is what we're going to be using as our explanatory variable or our predictor variable. And then the distance that the ball travels is going to be the response variable. So the club head is going to explain the distance the ball has traveled, maybe if you want to think of it that way. And in a previous class, in your, ever since you started plotting points in some sort of previous math class, we would say that the club head speed would be the values for our x-axis, and the distance the ball traveled ends up being the values on the y-axis. So we would have a value not only for the x, but also the y value. And if I plot this point here, I can plot these points on a single graph to create what we call a scatter plot or a scatter graph. So you'll notice here I have each one of these points on my graph down here is representing the data here from the pair of points that's the relationship that we're going to investigate. So this scatter plot or scatter diagram is what we're going to use to show if there is a relationship between two quantitative variables. So our quantitative variable down here for our explanatory variable, again, is the club head speed. And then our quantitative response variable up here is our distance the ball travels. Now, when I look at this scatter diagram, one of the things that I want to start to notice about the diagram is, are these dots lining up in any type of linear fashion? So are they making some sort of a line, if you will, as we move from one edge of the graph to the other? And sure enough, you can kind of see that they're sort of lining up in some sort of linear type fashion here. And the other thing that we want to start to notice is the direction that the dots are starting to line up. So when we want to look at interpreting scatter diagrams, we're going to look at the direction that the dots appear to fall in to give us some sort of information about that relationship we're looking at between my two quantitative variables. So here you'll see I have two diagrams or two images here on the very left. Now, the first graph you see, we have all of our dots lining up in some sort of linear fashion, and you'll notice that these dots are increasing as I move from the left to the right. So all the dots are rising or increasing as I move from the left to the right. We would say that this is a positive direction. And to interpret that positive direction, we understand that as my x values are increasing, at the same time, the y values must also be increasing. So my two variables then are behaving in the same direction. As one variable increases for a positive direction, the other variable is also going to increase. Then we can move on to this graph here, and when we look at this one again, it's in a linear fashion, but notice that as I look at the graph from the left to the right, the graph is actually falling from the left to the right. And if you remember from, again, a previous math class, that would indicate that the graph is giving off a negative direction. So it would have a negative slope from a previous term. The negative direction of our scatter plot here indicates then that as the explanatory variable is increasing, our response variable ends up decreasing. So our negative direction ends up indicating that as one variable goes up, the other variable goes down. Specifically here, we're saying that as the explanatory variable increases, the response variable is therefore going to decrease. The remaining three scatter plots you see up here are non-linear and therefore have no relation. Now we want to be clear in the fact that what we are looking at in our scatter diagrams for this chapter are linear relationships, linear scatter plots. So although this graph here that I am indicating is making some sort of curve, as well as this other graph here, we have some sort of curve happening on each of these two images here, they're non-linear, and therefore we don't really care about interpreting them then for this particular chapter. And finally, the very last image that you see over here, notice that these scatter plots aren't really forming any type of definitive increasing or decreasing type of a linear line or a line. So we would just simply say that there's no relation when we look at interpreting this last diagram over here.